All right, we get to practice factoring more today, but this time we're going to factor some special cases. So let's go ahead and start by looking for a pattern. So if I ask you to factor each of these trinomials, so I'm going to give you 6, and I want you to try to pretty quickly factor them because you should be getting relatively good at this by now. So let's see what you got. Did you get x plus 3 squared for the first one? X plus 9 times x plus 1 for the second one. Maybe m plus 3 times m plus 12 for the third one. Maybe m plus 6 squared for the next one, where m plus 6 times m plus 6 is fine. Maybe k plus 25 times k plus 1. And then maybe here, k plus 5 times k plus 5, or k plus 5 squared. Okay, what I want you to notice about these, and maybe you notice, like the first and last terms of the first pair are the same. The first and last terms of the second pair are the same. And the first and last terms of the third pair are the same. But some of these happen to be perfect square trinomials and some of them don't. So, which trinomials have a pair of binomial factors that are identical? Okay, hopefully you're noticing all the ones that I put the squared by. I want you to see if you can see what the relationship is between the middle and last terms of those trinomials when they have an identical pair of factors. So you're looking for the relationship. What's the relationship between 9 and 6? Okay, and then there should be that same relationship between 36 and 12. And then there should be that same relationship between 25 and 10. What I hope you figure out is if you take the square root of that last term and then double it, you get your middle term. Like the square root of 9 is 3 times 2 is 6. The square root of 36 is 6 times 2 is 12. And the square root of 25 times 2 is 10. So this, you have done this before, but we've worked backwards. Like we did a plus b squared and came to here. Now I want you to be able to recognize a perfect square trinomial when it's in this form, standard form, and then go ahead and make that into the factored form. So if you see a squared plus 2ab plus b squared, you should know that that factors into the quantity a plus b squared. And if you see a squared minus 2ab plus b squared, you should notice that that factors into the quantity a minus b squared. Okay, so let's start here. I want you to factor m squared minus 6m plus 9. Okay, so what we're going to try to do is notice that that's a perfect square. You can multiply it by 3 times 3 or negative 3 times negative 3. Since this is a negative number, we're going to guess that this is m minus 3 times m minus 3, or m minus 3 squared. And if you wanted to check and make sure that you're really right, you can multiply it out, m squared minus 3m minus 3m, so that's minus 6m plus 9, and it looks like it checks out for us. Okay? I want you to try this one, and I'm going to show you 2 different ways to do this. Okay, so factor 4m squared plus 24m plus 36. What you might notice automatically is that that's a perfect square and that's a perfect square. So maybe the first thing you want to try is taking each of their square roots. So that's 2m plus 6. And let's try if we square that, if we can get it to work. So we'd have 2m plus 6 times 2m plus 6. If we got that, we'd have 4m squared. That would be 12m and another 12m, so plus 24m plus 36. Okay, so that does work, but we're going to notice something. This is not completely factored, and the reason why it's not completely factored is because in here we have a common factor, 2m and 6. 2 goes into both of these, so really I'm having 2 times m plus 3, that whole thing being squared. So do you remember we can distribute here? So I might write that as 4 times m plus 3 squared. Okay, I don't know if you like that method or if it seems a little too complicated. The other thing to avoid having to factor it out once you already have it is just to take the GCF right out at the beginning. And then we have 4 times the quantity m squared plus 6m plus 9. And you're going to notice, again, this looks a whole lot like the first one. So we have the 4 already pulled out, and then we have m plus 3, the quantity squared. can notice we get the same answer both times. This is in final form, final factored form. You are not allowed to leave it as something like that, 2m plus 6 the quantity squared, because they both have a common factor. Okay, so here's one. The area of each of a square is 16h squared plus 40h plus 25 inches squared. You're trying to find the length of each side. And you know that a square, you just multiply side by side to get it. So we're pretty lucky. I would just try to guess the square root of the first and the last terms and see if that works. So square root of 16h squared is 4h. Square root of 25 is 5. So we think this is probably 4h plus 5 squared. If we double check, that's 16h squared. That's 20h and another 20h, so plus 40h plus 25. Lo and behold, that checks out. It looks like each side is the same. Each side is 4h plus 5. And we're going to label it so it's 4h plus 5 inches per side. All right. Another thing I want you to notice, another important special case, the difference of two squares. So again, we've gone from the second way to the first way. But now what I want you to recognize is every time we have a difference of two squares, so you see a squared and then a subtraction, b squared, so a perfect square minus another perfect square, we can always factor it in this form, a plus b times a minus b. Okay, I like these because if you can recognize the patterns, it makes it really quick. So here, factor a squared minus 16. So notice, perfect square, perfect square. So it looks like this is a difference of two squares, which leads me to believe that this should factor into a plus 4 times a minus 4, or a minus 4 times a plus 4. And if I double check that again, be a squared, and that's minus 4a plus 4a. So lo and behold, those two terms will cancel out, and we have a minus 16 at the end. So it looks like we factored it correctly. The answer that I'd have you leave is a plus 4 times a minus 4. Okay? All right, try this one for me. Factor 9b squared minus 225. Okay, this is going to be similar to the last thing I just did, but or not the last one, but a few times ago. So one thing I could say, hey, 9b squared, that's a perfect square, 3b. 225, that's a perfect square, 15. So I think this is 3b plus 15 times 3b minus 15. Okay, and again, that's going to be 9b squared. This negative 45b and 45b will cancel out. We have negative 225. So this seems to check out, but I'm wondering if you notice that something is wrong with it. Okay? I hope you notice that 3b and 15 have a common factor. And again, 3b and 15 have a common factor. So I would have to factor it out and go further. So I'd have 3 times b plus 5 times 3 times b minus 5. And I'd probably pull these out and put them first. So we have 9 times the quantity b plus 5 times the quantity b minus 5. This would be the final factored form. Okay, and kind of like I did last time, if you wanted to do it a different order, you could factor out the GCF first. So 9 goes into 9b squared and to 225. So it's 9 times b squared minus 25. And then we can see that that's 9 times b plus 5 times b minus 5. So both times we work out, we get the same answer, but you have to make sure you keep going and go all the way. All right, try this one for me. 5x squared minus 80. You may notice that neither of these is actually a perfect square. 5x squared is not a perfect square, neither is 80. So I'm going to try and see if they have a GCF, which I know 5 goes into both of them. So it's going to be 5 times x squared minus 16. Now this looks nice because x squared and 16 are both perfect squares. It's a difference of squares, so I think it should be 5 times the quantity x plus 4 times the quantity x minus 4. That's my factored form. All right, last one. Factor 100b squared minus 36. So again, you have to completely factor this, so you pick whatever method you want. So I'll notice that that's 10b, the square root of that, and that's 6. So I usually just like to do 10b plus 6 times 10b minus 6 first. But I need to make sure I'm really cautious because the even numbers, we need to factor that out. So then I've got 2 times 5b plus 3 times 2 times 5b minus 3, which in the whole should leave us 4 times 5b plus 3 times 5b minus 3. Again, just notice these have a GCF. You could have pulled the 4 out right away, and it would be 25b squared minus 9. Then you'd have 4, and that would be times 5b plus 3 times 5b minus 3. You pick your poison, whichever way you like it better. And hopefully these special cases, they're just standing out to you right away, and we'll see how you do.